the session. So we're now being recorded. And I want to go to this one right here. Does everybody see this?
Yes.
Okay, thank you. Okay, so this is the one problem that we went over for confidence intervals. And this is the N. Haynes report on a group of women, 20 to 29, and the sample size is 654. With this sample, we got a sample mean of 26.8, and that is a pretty large sample, especially coming out of a population that was 20.6 million people in the same age group. So I'm sort of looking at the numbers that I need to do to create a confidence interval. And I need the sample size. I need the X bar, the sample statistic. I need the standard deviation. Okay, and this is the population standard deviation. Some of the things that I need to know, or conditions that I need to be aware of, is that the sample was a simple random sample. The population is a normally distributed population. We do not know the population mean. However, we do know the population standard deviation. Okay. So here is sort of the procedure that we need to do. So to estimate the unknown population mean, again, this is the purpose. This is the target that we're interested in, the unknown population mean. That's why we want to use an estimate, that is the sample mean, in place of the unknown population mean. So we really want to know what mu is in this context. Okay. The second step would be taking the average BMI, and that is 26.8. We have a simple random sample. We have a sample that's large enough, and we know that the normal distribution is in play. So we're taking the population standard deviation and dividing it by the square root of the sample size. So 7.5 over the square root of 654 is equal to 0.3. Okay, this term right here could be called the standard error. Okay, the standard error. And so 0.3 is the standard error. Okay. So here are my scribblies. Sorry for this, but n is equal to 654. The sample statistic for this is 26.8. The standard deviation of the population is 7.5, and we want a 95% confidence interval. So let me just use this term right here, estimate plus or minus the margin of error. The estimate is coming from X bar. The margin of error is made up of the standard deviation over the square root of 654, and we're going to be using 2 for the 95% confidence. Why am I using 2? Okay, 95% is 2 standard deviations away from the mean. That's why we're using the answer, the number 2 with this. So the margin of error, I'll get back to this in just a second. Okay, so here it is. We are using the empirical rule, 68, 95, 99.7. This is the rule that gives us 2 standard deviations away from the mean. All right, so 2 standard deviations away from the mean would be a product of 2 times 0.3. 0.3 was the standard error. 2 times 0.3 will give us 0.6. So we're using the estimate, X bar minus 0.6 and X bar plus 0.6 to get our confidence interval. So when we do this, we're using 0.6. In this particular case, 0.6 is called the margin of error. 0.6 is the margin of error. So we're taking the estimate plus or minus the margin of error, and that would give us 26.2 and 27.4 as the limits to that confidence interval. So the interval goes from 26.2 and 27.4. Now, I'm going to give you a statement that sort of says what is really happening here. We are 95% confident that the mean BMI for this population, mu, okay, we are 95% confident that the mean BMI of all young women is a value inside the interval of 26.2 and 27.4. So this phrase right here, this phrase is our conclusion about the 95% confidence interval. Does everybody understand what I'm doing? I'm taking this language right here and making that the interpretation of the 95% confidence interval that we just stated. So in the end, the z-score is 1.96. We're turning that into 2. This here is the standard error, and that is equal to 0.6. So I'm sorry, 0.0. So 2 times 0.3 is 0.6. And that's how we get these numbers right here. Taking the estimate, 26.8 plus or minus, this would be minus, this would be plus, and that's how we build a confidence interval. Questions? Okay. Questions? Please chime in. This is the time to ask questions.
This doesn't have to do with confidence intervals. Is that okay?
Yes, ma'am. Go ahead.
On the homework for chapters 8 and 9,
Yes.
I don't know if we went over it in class, but it was having us do table B, like randomizations for like numbering. I don't even know what it was, but are we gonna have to do something like that on the test?
Try to explain the middle part of your question. What problems
I forget.
are you?
A lot of the questions were just like use table B. I don't know, something.
Okay.
And it was like you had to use the table to randomize the order of the numbers.
Okay.
Like to group them.
I think I know what you're asking, Madison.
Okay.
Yeah, there might be a question about that. I think it's fair to think about how you would get a random sample using the table. I guess you would need the table to do that. So I would have to at least put something on the exam that goes along with the table. Is that what you're suggesting?
Yeah, I was just wondering if it was going to be on there because I wasn't really sure how to do that.
Okay. I don't think I can get there quickly.
That's okay.
Maybe. But if you want to, I can meet with you during the week or whatever, and we could go through it.
Okay, yeah.
Okay.
No worries.
All right. Other questions? Okay. So let's try some questions that go along with chapter 16. Okay. So here is a question. What is meant by statistical inference? What do you think?
Hey.
Okay. And what are your thoughts there, Madison?
Oh, I'm assuming drawing conclusions is like making a statistical or a confidence interval. So, and you draw that information from a sample size. So,
Okay. So you're thinking that A is the conclusion, is the answer. Okay. So drawing conclusions about the population based on the information that you get from a sample. So we're taking a sample, and the sample is meant to estimate the population parameter or the population mean. And so we have to, with a sample, we have to also determine a value of error that goes along with that estimate so as to understand the possibilities of what the population mean might be. Okay, so A is the right answer. Okay, so these simple conditions for introducing basic ideas about inference for the population mean, which of these is not included? What do you think? Okay, do we need a simple random sample? Yes. Do we need some information that tells us that the population distribution is normally distributed?
yes,
Yes. Do we know the population mean?
no,
No. Okay. We do know the population standard deviation. So that's what I was trying to emphasize with my scribblies, is to think about how this would all play out. And we, in our hands, the population mean is not known, and therefore that's why we need an estimate. And our best estimate is the sample mean. Questions about this? Okay. Why might we need a population to follow a normal distribution in order to infer something about mu? Okay, we haven't really said too much about this, but there is what is called a sampling distribution. A sampling distribution is a situation where we do multiple sampling. Okay, let me go back and show you what I'm saying. With this slide right here, slide right here, we come to know that we're doing multiple sampling, okay? A simple random sample with the size of 654 is one sample. We could take another sample, a third sample, all the way up to many, many, many samples. And those many, many sample means can be put into a distribution. And so we're hoping that the sample means, or the distribution of the sample means, will give us an estimate of the population mean. Questions? Okay, so when we're doing inference for a population mean, is it common that the sample mean is known? Well, let me answer this question too. If we don't know the population mean, in reality, if we don't know the population mean, we probably don't know the standard deviation, the population standard deviation either. So the answer to this is false. But what we can do with problem solving and with our effort to build confidence intervals, we're assuming that we do know the population standard deviation sigma. But in real life, if we don't know the population mean, we probably don't know the population standard deviation. Okay. Okay, why is it sensible to use X bar as a guess or an estimate for mu? Is X bar always going to be equal to mu? No. Is X bar going to be the same from sample to sample?
No.
No. Okay. The sampling distribution of X bar tells us how close X bar might be to the value of the population mean mu.
Yes.
Yes. Okay. X bar is the easiest statistic to calculate. That's more funny than it is serious. Okay, so we have done repeated sampling. X bar should be within of population mean 68% of the time. Okay, so we're using 68% as the confidence level for this particular scenario. So how would we create, or which of these is creating the margin of error? Okay, how far away from the mean is one standard deviation away? What's the area under the curve at 1 standard deviation away from the mean?
68%.
68%, okay? So in this particular case, we're not thinking about multiplying 2, okay? That's 95%. In this case, we're looking for a z-score that is consistent with 68%, and that's 1 standard deviation away from the mean. So which one of these would be the right answer?
D.
Okay, D, right? This is called the standard error. Right here is called the standard error. Now we have 2 here, and we probably should have put 1 here, okay? So you could think of this as plus or minus 1 standard deviation away from the mean times the standard error, okay? Questions? All right. So the purpose of a confidence interval for mu is to give a range that is likely values within that confidence interval. The purpose of this is what? Okay, we want to know the unknown population mean. So C is the right answer. What do we hope is within the confidence interval? Well, broadly speaking, we want to know an unknown parameter. Okay. All right. Let's start thinking about this as our last question here. What are 3 components of a confidence interval? Okay, again, we're using an estimate of the population parameter. That's X bar. We need a confidence level, and we need a margin of error.
Aren't we using the sample size though?
Okay, the sample size, that's a very good question. Okay, that's a very good question. The sample size is actually in the margin of error.
Okay.
One more time. Here we go. Margin of error. What is the margin of error of this statistic? If the estimate in our confidence interval, that's X bar, okay, if that is negative 0.6, okay, and the confidence interval for the same estimate, okay, is 0.8 to 0.4, what is the margin of error?
I feel like
It's
this one
D.
should. Oh,
Go ahead, Sarah.
I was going to say it's D because it went from negative 0.8 to negative 0.4, but that's just an
Okay,
educated guess.
well, okay, that's a very good estimated okay guess. Okay, so in our sort of way of thinking about this, we take the estimate plus or minus the margin of error. Okay, Sarah, let's have a little discussion there. Wouldn't you say that there's really a measure of the margin of error on both sides of the estimate? So 0.4 would give us the difference between the low and the high part of the confidence interval, but the margin of error is 0.2 because it's going to be a margin of error on the left side, and there's going to be another margin of error on the high side, on the right side. Does that make sense, Sarah?
Yeah.
Okay, very good. Okay, so I'm going to get out of this and come back. All right. All right. I want to stop sharing. Okay, there we go. Okay, so we have a few more minutes. And what I'm suggesting that we do is that I have 3 different chapters. And in each one of those chapters, I have PowerPoint slides. Okay, so we have 3 different sets of PowerPoint slides. Is that right? Chapter 8, Chapter 9, and Chapter 16. And in each of those PowerPoint slides, we have questions that go along with the chapter. All right. So I'm suggesting that you use the PowerPoint slides and the questions that are associated with each one of the chapters to start to think about a guide that would lead to a last exam. Is everybody understanding what I'm saying?
yes. Yes,
Okay.
thank you.
Okay, and so that's the guide that I would do. All right. So, is there any other questions?
No, but will you be available by email throughout the week as we
Yes.
study?
Yes, ma'am. I will.
Great, thank you.
Okay. Other questions? Okay. Well, if that's what we can do with one session, the last session, I think we did some good work. So I'll bid you a good morning, and have a great day and a great week. And we'll see each other or hear from each other at the end of the week. All right. Thank you very much again. It's
Thank
been
you.
an honor to be with you all.
Thank you.
Have a
Thank
great one.
Thank you.
Hey, Dr. T. I just had a quick question.